This is a question of CSR Net 2024. The question is, what is the cardinality of the set of real solutions of the equation e to the power x plus x equal to 1? First option is 0, second option is 1, third option is countably infinite, and the fourth option is uncountable. To solve this question, I will first rewrite the equation by bringing 1 from right hand side to left hand side. So solution, so e to the power x plus x minus 1 equal to 0. So we have to find the cardinality of the set of the real solutions of this equation. So let us now construct a function. Define a function f from R to R by f of x equal to e to the power x plus x minus 1, where x belongs to R. Now look at this function. This function is differentiable everywhere, at every point of R, and the derivative of f dash x is e to the power x plus 1 for all x belongs to R. Now observe that f dash x is always greater than 0 for every x belongs to R, because e to the power x is always greater than 0 and 1 is also greater than 0. Therefore their sum is also greater than 0. Therefore we can conclude that, so this implies f is strictly increasing on R. So what can we conclude from this? We can say that f must be injective, and therefore the equation f of x equal to 0 has at most one real solution. Now recall Bolzano's theorem. Bolzano's theorem says that let f from closed interval ab to R be a continuous function if f of a is less than 0 and f of b is greater than 0, or f of a is greater than 0 and f of b is less than 0, then there exists at least one x in the open interval ab such that f of x equal to 0. So Bolzano's theorem basically says that if f of a is less than 0, that means f of a is negative and f of b is positive, or f of a is positive and f of b is negative, then there exists at least one root of the equation f of x equal to 0 in the open interval ab. I will use this theorem. Look at the function, our function fx equal to e to the power x plus x minus 1. Now calculate f of minus 1. So f of minus 1 is e to the power minus 1 plus 1. Yes. F of minus 1 and this will be minus 1. So 1 by e minus 2, and this is less than 0 because since e is greater than 1, so 1 by e is less than 1, and from this we can conclude that 1 upon e minus 2 must be negative. And calculate f of 1. F of 1 is e plus 1 minus 1, and this is e which is greater than 0. So if we consider the restriction of f to the closed interval minus 1 comma 1, then it will be continuous, is continuous on minus 1 comma 1, and f restricted to minus 1 comma 1 applied on minus 1 equal to f of minus 1 which is less than 0, and f restricted to minus 1 comma 1 applied on 1 equal to f of 1 which is greater than 0. Therefore, by Bolzano's theorem, we can say that there exists at least a point x0 in the open interval minus 1 comma 1 such that if restricted to minus 1 comma 1 applied on x0 equal to 0. That means f of x0 equal to 0. So x0 is a real solution of the equation f of x equal to 0. We have already seen that the equation fx equal to 0 has at most one real solution. Therefore, we can say that x0 is the only real solution of the equation f of x equal to 0. Therefore, the cardinality of the set of all real solutions of the equation e to the power x plus x equal to 1 is 1. So option 2 is true.